So this session is about a continuation to the previous session of the advanced water solutions. And not to go more about what is it about, but more or less is innovation across the technology being used for the water sector. We have three presenters, and the three presenters are from different angles. Of course, it's the private sector. We have Warner, and we have Shahada, and we have Faris. Warner is from Germany, and Shahada is from Egypt, but Warner will be presenting an international and focus with a bit of what they are doing in Jordan. And Shahada will be focusing their experience in Saudi Arabia, right? Plus also some information about the innovation he's bringing to discuss. And Faris will be focused more on some of the technologies that are being used in Jordan of an interest, such as SCADA and so on. So let's start. We have, fortunately, 1 hour and 15 minutes. Since we do not have lots of people in the room, we're going to debate. So we'll leave the presenter here and the other presenters to be down so that they cannot block the screen, because the presentation will be on the screen, and then we'll interact with them. Let's start with an international lesson learning by Warner. Warner have a civil engineer background for 33 years. He's actually younger than me with 1 year. I don't want to mention the age.
I'm over that step. Excuse me, you understand English? English is fine.
Yes. They are.
We understand.
And
he's more younger than us.
Thank you so much. This is very encouraging. He has been working in the pipeline industry and the sales, and he had been working in lots of places, such as, of course, he started in Europe, Asia, South America, and Australia, and Africa, and probably in the Middle East also he has done some work. He will be talking to us about it. I forgot to mention to you, my name is Ismail Ibrahim. I work with Aqua as a senior water, sanitation, climate consultant. Worked for United Nations for 35 years. And now I'm a senior also water and sanitation, climate policy analyst, part-time with United Nations. Warner, you're welcome to the presentation, and let's interact. Thank you very much.
So thank you for being here this afternoon. One thing up front, if you have any question, please raise your hand and ask the question in the presentation, so because this may help you in the further understanding, and maybe even others have same non-understanding or not a question from my presentation. This one, please. One point up front, we talk about a lot about water here in the whole conference, and there are two main issues. The one is having enough water in general, raw water, and the other is the water we have, not to lose it on the way from in a few kilometers from the well to the consumer. And this is where I want to focus on. I can't help much on the raw material sourcing in general, so this is not my field of activity, but I can bring to your attention what I experience over all the decades in how this is tried to organize and to manage, and what solutions are available. Find the right one. One gravity sewer pipes. I'll tell you what is there, you may listen to me. The other sector is the water pipe. So if I was in Singapore with an official, and he was looking for more budget, and he needs argument how to find more budget. What is the argument? Of course, there's damage here, there's problem there, but it's underground. No one sees it. This is the problem with pipes. It's underground. If a road is bumpy, money is being spent. But underground, there's no spending, only if the road is cracking. Then we made a simple calculation of a 1 kilometer of a gravity pipe, diameter 500 millimeter, 30% filling. What will be extracting into the ground? Every time we talk about environment, what is really exfiltrating in a, and we started what we could think in a second, in a minute, in a day, in a year. We came up with only 3% of what is flowing through, liter per second, 0.09 liter per second speed, liter per hour, already 300 liter per hour on a kilometer, on 1 kilometer. Cubic meters, say, per day, per year, and the requirement for renewal with any material, irrespective with technology, with provider, which supplier, the minimum requirement for renewal is not less than 50 years of a lifetime expectation. This is why pipes are being renewed. So if we say, if we renew a pipe with whatever system, 140,000 cubic meter on 1 kilometer of renewed pipe is not going into the ground. And I think people who renew pipes with this condition, they belong to the greatest protector of the environment we have. If we understand that in 1 cubic meter of water, you fill 1 liter of oil, it's polluted. And I would say it's even more than, or a little more, you won't drink it anymore. With multiplied this amount with that 1,000, in 1 kilometer of a small size pipe, we pollute 140 billion cubic meter over 50 years, full stop. This is what a cracked sewer pipe causes the groundwater, where groundwater is precious for the potable water. Europe. Loss of water from we have water from the source to the well, in average 30% loss. We have countries on earth, they got 50-60%. I know Jordan is not less than 50% loss of water. The lack of water on one hand, on the other hand, we are having the water, and we are missing the water on a few kilometers, half of it. One step back. How long does a pipe last? Literature, experts say anything between 60 years, 150 years. I'm pretty sure it will not be 300 years. Any asset owner can make his own assessment. He decides, my pipes are lasting on average 200 years. I'm happy. If you take the 150 years, deduct 50 years already elapsed. Because since construction, 50 years already gone. It's an easier calculation for me, 100 years. If you say the average life cycle of a pipe is 100 years, that means any asset owner needs to renew his network with 1% per year to keep the status. There's no improvement. because all the others will, the 99% will get elder already. So every year 1% to keep it. In how now to address that? In Europe we do pipe assessment, we know the leakage points, so we go there. We do some inspection where we can do inspection. In Germany, I know the figures, we have 0.8% of the network per year with all technologies, also trenching, open cut of the water pipe, and 1.1 in the gravity. Why? Because the attention is on the environment, gravity, pollution. In Singapore, they do renovation now 28 years. They have a simple rule. In the age between 20 and 40 years of pipe age, they make inspection. If they find something, they renew. If they find nothing, okay, leave it. Anything beyond 40 years, general renovation. They got the money. Okay, they can do that. This is their rule. China has public pipes 3.4 million of cubic meter of kilometers. Sewer pipe about 1 million, and they say the 100-year rule would be 80,000 kilometers per year in the country. They say any 50 years, same style renovation. We are financing China, they can do it. Other countries, we need to look on our spending. We don't have that efforts, but we need to be aware that 1% or 0.5% is a guideline we are going for, or we should go for. This is what I said before. Take the calculation, 50 years consumed, 100 years remaining, 1% in general. With a discussion of the local situation, which depends, but we are plus or minus, we are there. What can we do? We can do open cut. I'm coming from construction, so this is a good solution. But I doubt that we are having the time to reconstruct everything in the dense cities with the open trench. And I doubt that we have the money for it. But I think the time is more nervous and sensitive than the money. In the inner cities, we can't open the road anymore like this in the metropolis. So lining in general with different systems is a good option. And I want to show you one of the options. There are several ones for slip lining option. We can do different methods. The demand of lining is the quality of a new pipe. I don't talk about the repair. Repair has a very short, let's say, lifetime expectation of about 10 to 12 years. I talk about the renewal. Renewal means in the condition of tightness, stability and duration and performance in practice like a new pipe. This is renovation. And the ISO standards say not less than 50 years. Not, it is 50 years. This should be a minimum assessed by standard-based assessments, not less than 50 years. That's why my calculation came before on the 50 years. Lining, if we have a pipe which is corroded, cracked, damaged, sometimes deflected, we need some information about the diameter, and it needs to be cleaned, and we need at least a day or 1.5 days of having the line free. Sections 150 to 300 meters in a day. With the glass fiber reinforced liner cured with UV light, this is at the moment the most common solution worldwide. We do, with our company, about 1,000 kilometers a year in more than 50 countries at the moment. We serve the material technology, and we do, for example, frame contracts in the Emirates, in Qatar, in Kuwait, some. This is actually at the moment in the region the activity. There is little in Bahrain, but other than that, I think we had no really attention to that technology yet. The material is made on the size of the pipe, with dimensioning on the wall thickness, pulled in with a winch, left and right side closed, inflated by air to fit to the surface, and then cured with UV light with a machine which pulls we call it light train through to the closed sector, and let's say a diameter 300 is done in about an hour, curing. Plus before, of course, winching in and inflating and then cutting and reconnecting. It doesn't matter much whether it's a gravity or a pressure pipe, water pipe. It's the same process, only inside the material we have different layers, because for gravity pipe it's only the stability from outside loads, of course the abrasion. For pressure pipes it is the outside loads, full static loads, then the inner pressure, vacuum shocks from pumps, and of course the flow through, and in potable water is another resin because of the potable water requirement of food. The material is pulled into the whatever manhole, shaft or open pipe. Before there is a new connector, that it is everything is new, not the rest is the pipe end is an old one. We serve that from different America, Europe. This is where I'm living in. We had started the factory in China, but after COVID we skipped that. We couldn't access for 1 year. So the building was there, and then we saw the government rule protect us to continue, so we stopped it. And maybe it was not too bad at the moment, because I see that a lot of copy is going on. And we have 2 factories in Japan, because they do that for earthquake protection. Non-pressure pipes or gravity, we do pressure pipes, potable water, any other medium, raw water, industrial, not oil, not gas. We provide the systems, the recurring systems. We do also training education sessions to enable the local companies to install the materials. After installation with the connector, and then before filling the potable water pipe here. Few words to the installation, which I explained. You have the empty pipe, the liner. We call this the liner is differently packed, but this is more for visuality. This is filled in, pulled in, and then cured with UV light of the machinery. After that, cut, reconnect, and at the end, this material is compressed. This is loose, but it is stretched with the pressure, and after curing, this same material. And this is from a 2 meter diameter. Same thing. We made this is. I was there. I said, cut it for me. It was in Korea, in Busan, in the south. This is my personal sample. I always carry with me. I don't give it. I had to cut it for a ministry. It was wider before, and I said, give it. I said, no, I don't give it. Then I said, give it for 2 hours. We cut it. I said, give it back to me, please. Yes, I do. And now it's only half. But this is now my personal sample. This was a section 220 meter long, 2 meter with this thickness. The box folded along was 32 meter long, 2.8 meter wide, 3.5 meter high, 45 tons. One piece. Pulled in 4 hours, inflated in 2 hours, hardened with the machine in, I think it was 16 hours. So after 3 days, 2 meter diameter, 220 meter, reconnect, go.
How many years will
Actually, we have to, any of this lining, not also slip lining, they have to
You need to
prove.
use the mic if it's
Oh,
up.
sorry. Sorry for that. It has to prove not less than 50 years. There's an ISO standards for different, like design, like tightness, abrasion, and of course pressure. They assess the material for not less than 50 years. This is what we have to show, otherwise we are not in the category of a renewal.
and how much the cost reduction will be for replacing the line compared for the
The material itself is more expensive than a normal, let's say, steel pipe or in gravity a concrete pipe, but the duration is a saving. Years ago, I was of very strict opinion, this is not a market, India is not a market for us. Because 100 rupee is a monthly salary of a worker. They can dig holes with cheap money, you can't even look into it with a lamp. No way. They do a lot of this lining. Why? It is so long lasting in the traffic to do it. Normally we can say, outside in the sand, if the pipe is 2 meters deep, no groundwater, go there, dig it up, make a new one. You have space, you have the time, it's cheaper. But any proper asphalt covered road, 30 all over, material plus installation versus open cut, 30 to 40% cheaper than regular construction. And of course faster, because regular construction of a kilometer of any will last weeks, months, and let's say this one, 2 meter diameter, that would last 1 kilometer we made in 3 weeks, this will last a year and plus. This is the machine who guides the process. You have seen the material is put in. Then this light train, this one with the lamps in here, is they have flexible parts, so it can be levered down and feed it in one end when the other end is closed. When the compressor air is lifted up, the material lifts up when you blow air from one side. It's good enough to shift that in and close this other side. Connected with the cable. The machine has a QR code scanner, so the material itself has like a personal QR code. Get it on a reader from the machine. Machine knows, okay, this is diameter 2 meters, this is 24 millimeter, and this is my speed. And then the operator gets the start button, and the machine pulls the light train with a controlled speed through the pipe and cues it. If you would get out in the sun, this material, which is cut from factory, so it's from real production, this would be hard in 4 minutes. In the near wheeler. If one want to try, and that's why the 4 minutes is the touching of the light train going through, and it depends on the thickness, of course. So that's why thicker, larger will need more time than, of course, a small time. This is the control panel. Everything is recorded: pressure, speed, temperature, and so on. At the end, when you talk about quality control, every product has a quality management, it has a quality report, but that ends at factory door. Full stop. Process, quality, delivery, invoice, pay, done. There's a warranty period, yes, but the quality control is over. In this step, when the line has a QR code, which is fed into the machine, and the local curing parameters are working on top to complete the process, there's a complete installation process till the final finish of the product. We won't have that, not even in a new steel pipe, because when it's laid, it's only the quality report from factory, nothing on site. There's only installation steps, but not as a complete ID. This can be given to the whoever company owner or to the pipe owner as a final quality ID. This is, yeah, well, I was in an office. They said, "This is a very nice pipe. Why you show this as being renovated? They pay a fine now." So can be cracked, can be whatever. So this is a water pipe which was had some corrosion. It was nice and straight, but I think you have seen more ugly things.
This is nice.
Yeah. Yeah, different shape, because the material itself is stupid. It follows the circumference. So even box can be made or oval. So it is only about the circumference. The material is made with downsizing and has a stretching of about 10% tolerance to match really process. Yeah. Material glass is wrapped as a bandage, has different layers. In gravity has an additional abrasion layer even. See, my wife says, why you always go next to the manhole?
See your work, huh?
Compared, we had the pricing before with the trenching. Compared with trenching, which is the upper gray line, if you talk about CO2 consumption, trenching consumes 3 times more than this kind of work, which is the yellow one. If this is an argument with the acid one. Last 2 slides. The United Nations sustainability rules, we have applied for a certificate, and we received the bronze medal in the ranking for the sustainability goals. This is our goals, the 70 goals from the United Nations, and we have a ranking we are in the top 35 countries worldwide of the EcoVadis ranking. With some asset owners, this is an argument. Some say, for me, only money counts. So, for you as an information, thank you for your time.
If you don't mind, can you keep it until we finish? If you don't mind.
Okay.
سجل بس يعني just write it down. Thank you very much, Rainer. I think it's very interesting. And I've been working in the sector for 40 years. It's the first time I knew that pipes have age. I know they get rotten, they get ruined, they get damaged, they get whatever. But now they have age.
Yeah.
Very interesting. And the second issue also, they can be rehabilitated while they are in the ground. And it is again to do with the cost. If somebody want to compare between put a new pipe or use an old pipe and the condition. Anyhow, colleagues from Amman, just keep your question if you don't mind. The second presentation, we put it, as I mentioned, as a debate because we are few. and then we need to exchange views and help the presenter also. The second presenter is going to be Engineer Mohammed Shahata. He is born 86. I wasn't supposed to speak about age, we said. But anyhow, he's like to have it put because he's younger than me and you. And he's Egyptian, has a master's degree in mechanical engineering, and also he has an MBA. He joined the company Heron Shet. Heron Shet, right? Heron Connect, sorry. Heron Connect utility and in Saudi Arabia, and he's going to present to us his kind of technology innovation, and again it's to do with piping at the coast area, right? Please, thank you. Keep your question until last minute, unless it's burning while he is speaking.
So, good afternoon, everyone. Thanks, Werner, for the nice presentation. I really like it. I'm Mohammed Shahata. I'm working for Heriknecht. It's a German company. We are a tunnel boring manufacturer. I'm going to present today the shore approaches using trenchless technologies. Somehow a few more years before Werner's work comes, so we bring the pipes on the ground and then they make the renovation. So this is actually where we live in the sector of energy, water, sewage, infrastructure in general. So my focus today is on the water scarcity point and flooding, also sanitation. That's where our machines or our technology got applied. So, as I said, focus on sewage desalination. That's where we think that shore approach might be existing. And this is the main idea of shore approaches. So, shore approach might be like an outflow. So, we bring water from land, we just throw it in the water. Or the other way around, we take water from the sea as an intake for example, desalination plants and so on. Or cooling, for example. The goal of this technology is to minimize some impacts on the environment, either the marine environment, also on the land side. So, also accuracy and clearness and of water, what we take or bring to the sea. Because what we take from the sea, for example, we're gonna somehow treat it. So we try to take the most cleanest possible water, or to reduce the treatment process as much as possible. And also the other way around, when we bring back in outfalls the treated water, for example, the very saline water back, we don't want to bring it to the shore, or bring it deep in the sea, where it can dilute after that. So, I like this picture because it shows our machine portfolios. What we're talking about right now for shore approaches is mainly done with these three circled machines. We're going to talk later in deep about them. But it's also nice to see the rest of the portfolio. So, the general idea of shore approaches is very simple. We want to make a connection between a point on land to a point at the seabed of in a deep of 300, 400, 500, 800, 1 kilometer deep. So we start from a shaft on land, onshore, and we bring the machine down. The machine starts excavating underground, also still in the water area under seabed, till we reach the point where the machine comes up, and then we have our line. Either we use it as an intake or an outflow. So This done through different technologies, same technology but different machine. And the selection of the type of the machine is based on the type of the whole project, like depth, length, and for sure the crucial point is the geology, where we are doing the excavation. I will talk briefly about the machine technologies, but mainly the application is the same, which is this connection between onshore and offshore work. This is, we're going to talk about the pipe jacking method, which is, from the name, it's explaining itself. We're just jacking pipes after each other till we reach, for sure behind the machine, till we reach the point. This is an overview of a job site that really on the shore area, where we can see here in the middle, this is the shaft where we start jacking from. So we have the pipes, I'm not sure if it's clear. We have the pipes here, we bring it down, and we use the jacking cylinder to push the pipe behind the machine, and the machine starts excavating. In the front you see the machine, it's the yellow part, start excavating. In this technology, we are moving the whole parts, the whole pipes behind each other. So as long as the time goes, as much more force we need. So that's why this type of machines, the length where I can excavate is somehow limited, because I need more force to move longer lines. The most interesting part, because what I just explained, which is a standard tunneling process, but what makes it different here in the outfall or sea approach is this point where I reach the target point under the seabed or at seabed, where the machine has to come outside. We have an extra module that has to be assembled to the machine, on the back of the machine, where the machine can separate itself from the pipe, from the line. Just to make, now I reached the point, now I need the machine to separate, and then I have my whole line. We have this hydraulically through cylinders, as we can see on point number 4, where the cylinders just push the machine against the first pipe, and then come this separation happening. And as you can see in step number 2, that we have divers connecting the machines with a lifting bar, which is at the end of the process at point 5, the machine will be lifted from an offshore crane. So this is the additional part related in the process regarding offshore activity and onshore activity. Here, as we can see, this is a live photo from a project. The machine was built from the middle of the sea, so it was like a tunnel at this point. Then the machine reached this target point. The divers connected the machine and it was pulled up. So this is the extra part that is connected to the machine if the machine is planned to make this offshore approach. Either you lift it with the machine, you lift it with the crane, or you just make let the machine goes up with using airbags. So sounds familiar from diving. We have some reference projects for those applications. I selected the projects to show here, which is in our region. So no one think it's a very advanced technology used only in the US or in Europe. No, it's been used here in our region. So the first project was in Algeria. It was a desalination plant. They made a sea outfall for 250 meters from the shaft. So the starting shaft, 240 meters in the sea. This was a recent project, and the recovery of the machine was in November 2022. It was done very successfully, and that's how where they do the outfall for the desalination plant. So after the desalination process, there's very saline water remaining. They have to bring it back to the sea to be diluted again in the seawater. That's the technology they use. Here are some photos, real photos from the project. So the machine comes here at the seabed, and then it was lifted with the airbags and then the crane. Second project was also in Bulgaria. So it was a 2,500 machine diameter, inner diameter part. We have 3 intakes lines, and as you can see from the drawings there on the right side, 3 intakes and 1 outlet. So the 4 of them was done with the same technology, which is the outfall intake, let's say tablet budget. The challenges in such projects are mainly the depth where I'm excavating, because I have the pressure of the whole sea above the head of the machine. Also the type of geology, which is below the seabed. Another reference project is in Morocco. Also desalination plant application, intake, outfall. It was 2 drives. One was 550 meters, the second one was 600, around 700 meters. The geology here was sand and clay, and it was done by a Spanish company, which is, it's my 3rd time to attend here. The first time was 2019. I came here first time hoping to bring the technology somehow to the country, and it's my 3rd time, and it happened. They had a project financed by the World Bank, and this company, this Spanish company, made the first, let's say, trenchless project in Jordania. It was for the rehabilitation for the lagoon area in Musaifa. Yes, Pepsi Lake, exactly. I was not sure if this official name is. So this was the pump-jacking technology. This was our machine. This is again more information about the desalination plant in Morocco. This here, the right side corner, the picture from the shaft, from the job site, the starting shaft. Next reference is in Kuwait, also sea outfall. This was water treatment plant, and then the treated water was then through in the gut. This was an English company, British company, and it was a little bit a long drive, so outfall tunnel length was almost 2 kilometers, so it was a little bit challenging. Another reference project in the US, smaller tunnel, 1500, tunnel length 250, it's a little bit short drive. Also, the challenging point was the rock in the ground where we excavated. But the technology was the machine was already able to excavate the rock, no problem. Next, also in Chile, so we had projects in the Middle East, projects in the US, also in Latin America. So this application, this technology is used worldwide. For sure, it's related to the country is directly on the coast. So if there's no coast, then it will be difficult for this application. Another project in Chile,
مشروع آخر في تشيلي
AVN 2000, this is the type of the machine, so ID2 to 2000.
المستخدم والمعدل
Two outfalls for seawater intake.
كانت تعمل في محطة معالجة مياه.
Drive length was 350 meters and 540 meters. Another project in Mexico,
مشروع آخر في المكسيك.
a little bit longer this time, so 1.7 kilometer and 1.3. It's also challenging.
7 كيلومتر هذا تحدي حتى.
We have more than 110 sea outfalls worldwide, so it's already proven technology used intensively in the last time, in the last years. We have 2,500 can be done meters for the outfall of the intake. The same application can be done, as I said, with different machine types. So this is another type, do the same objective of the project, which is a connection between onshore and offshore point. The difference here that in the connection between the pipes and the machine. Before it was only a concrete, reinforced concrete pipe, so I have to push the pipe and then bring the second pipe and push third pipe and so on. This type of technology, it's like a steel pipe connected, 12-meter pipe, already welded, and then we push it together behind the machine using this pipe thruster part. So this is equivalent to the jacking force that we get from the conventional pipe jacking machine. This is for sure, in some application it's more faster to perform the job. That gives us also a option. I will pass fast about the technology, also the project. Everything is same except how we move the line behind the machine. Project in New Zealand, I said this technology gave us the chance to make longer pipes. So we have here 2,000 meters, so 2 kilometers in one shot. Best daily performance was 42 meters. Second one, already we talked about, it's the same project in Mexico, but we have also used this direct pipe technology for this project too. As you can see, this is the pipe behind the machine, and then you can work in parallel. So you make some welding in the pipes, and then after welding, then you do the jacking. Direct pipe. Another reference project in Scotland, in the UK. This is another project in Mexico we talked before about. So this is, as I said, it's proven technology. We believe that this technology related to this somehow helping to reduce this scarcity of water in our region, because mainly the main application for this is desalination plants. With the direct pipe technology, we have a total of 27 sewer ports worldwide. We can reach 2 kilometers deep in the sea level. Thanks a lot for your attention, and I'm ready for questions.
Thank you very much, Mohammed. Very interesting again to see the pipe jacking and also how relevant it is to the water and sanitation sector, especially to do with the desalination and so on. It has a various kind of use, like the cables and so on. But it's add up to what Werner mentioned earlier. Werner comes and repairs, but Mohammed and his company, they come and install. So So matching between this and this. A question will be left for us to think about is the cost and the visibility. How much is it going to cost and how much is it feasible to your requirement. Although, and it's very relevant to our area because here desalination in the Gulf area and in West Arab, North Africa kind of countries, they depend a lot on desalination. The last presenter is going to be, and if you have questions, you can record it until last minute so we can ask. The last is going to be Faris Wakila. And Faris is his background is again civil engineer from Jordan Technology University, Science Technology University. And he has been working in the sector for 13 years on innovation, infrastructure, environment projects. He has overseen some designs and execution of using the SCADA. And he's specialized, focusing on IT, right? How it's innovative and relevant to the sector. He will have a video presentation, right? So it's different from the others. And he's a Jordanian, of course. He doesn't want to mention his age, but he's the younger among all of the presenters. MashaAllah. Please, Faris, come and take it close.
Thank you, Dr. Ismail. Believe it or not, this is a small leap in the bike in the country, in Jordan and in the neighboring countries. You can find this happening. In some countries, over 50% of the water will be lost in the network before it reaches the customer, and we can help in fixing that. I introduce myself. My name is Faris Wakila from the company Wakila. We were established in 1991. We deal mainly with wastewater treatment plants, non-revenue water equipment, instruments, flow measurement, industrial weighing systems. After successful projects, we have been classified by the Jordanian Ministry of Public Works and Housing as a first-class contractor in wastewater and drinking water treatment plants, second-grade electronics contractor, third-grade electromechanical contractor, fourth-grade water and wastewater, and fourth-grade building contractor. In the year 2005, we were separated into two companies, Wakila Contracting, which deals with turnkey projects and operation maintenance contracts. Wakila Engineering Services deals with non-revenue water equipment and instruments. Our mission is to provide proven solutions, save the environment, save fresh water, encourage plantation, and encourage the reuse of treated wastewater. Okay, our values to provide solutions with integrity. We provide solutions with high quality, and of course we claim to be excellent at what we do. How to conserve water? First, fresh water will go into the network. We do flow measurement, we do monitoring, leak detection, maintenance. So we increase the revenue water, then the water goes to the household, and it's turned into wastewater, and then we can treat that wastewater and reuse it into irrigation. How we do wastewater treatment? We provide case studies, designs, construction, operation, and maintenance of decentralized wastewater treatment plants. The whole cycle of this helps us improve, continuously improve, and to offer better solutions and better service. We are one of the few companies in Jordan that we have our in-house laboratory to keep up with the water quality from the treatment plants we have. Also, we have what we call the Wakila monitor, which is a small kind of SCADA system that we can connect several small wastewater treatment plants to one platform that we can monitor and check the status of the operation. This is a preview of this Wakila monitor. And also we can do SCADA systems for the bigger scale wastewater treatment plants, such as this kind of project. These are photos of a preview of some selected projects that we do inside Jordan, in touristic areas. This one is the airport, Queen Ali International Airport, in prisons, in hotels. This is again in the airport. This is in the University of Madaba. This is again in a hotel. And also in Wakila we do rehabilitation of existing old wastewater treatment plants. This can save a lot of money, investment costs in the wastewater treatment plant. For example, this is in the airport. This saved about 5 million JDs of investment. This is in Madaba and the Rasiya camp project. Also, it saved millions instead of building a new wastewater treatment plant. In non-revenue water equipment, we provide the whole cycle of the triangle of the non-revenue water, devices that serve to find the area, devices that find the line to pinpoint the location of the leaks. We have such equipment like the ultrasonic flow meter UFP20 from the company Tokyo Kiki. It is a very special ultrasonic flow meter that can actually be connected to 2 different pipes at the same time and can measure the flow from 2 different pipes. And it also can be connected to the pressure and flow data logger from the company Fujitecom. So you can have your data tabulated neatly on one table from the flow and the pressure. Also, we have the pipe locators, metallic and non-metallic pipe locators. The PLG from the company Fujitecom not only can find the location of the pipe, it can also measure the depth where the pipe is. So it has several ways how to do this. In terms of the leak detection, we have the normal listening sticks, but also we have the digital listening stick, which is more advanced with a digital screen that shows the leak lines that we have. We have the very special device of the DNR18 from the company Fujitecom. This device is excellent in finding and pinpointing leaks. It can do the noise reduction, several levels of noise reduction, so you can find the leaks more precisely. Also, the digital correlator LC5000. This is the best device in the market. It has 4 different sensors, and it can find the leaks to a very high precision from each sensor that can be connected on different parts of the network. Also, we have different kinds of instruments from flow meters, pressure gauges, water quality testing kits and meters, air quality meters, sound meters, weighing devices also, a few range of these devices. Also, we provide the necessary training for every device, so our customers can actually know and learn how to use such devices, because it is not very easy for someone to start with the device on his own. So we provide the necessary training. Why are we different? We don't only sell products. We provide over 45 years of experience in utilities and infrastructure. We combine civil engineering, electromechanical engineering, IT, and environmental engineering under one roof. We are the distributors for the best NRW devices in the local market. We also offer tailored solution, case by case, to give the best solution for our customers. Of course, we provide the best support, technical support, and after-sales support to our customers. So we like to leave good reflection on our customers, so they come back to us and they give us the recommendations that we need to keep working in the best manner that we are used to. So we are located in Amman, Jabal Werde. You are welcome to visit us at our offices, and we are also in booth B5 here today and tomorrow. If anyone has any question, please, you are welcome to join us. Last but not least, we always like to say, water is life. We have to save every last drop of it.
Thank you very much, Faris. And also I'd like to welcome the father of Faris, who is one of the establishers, who is here with us. Thank you very much for joining us. It's a very excellent presentation, actually. And what's amazing about it is the issue of the instrument and the equipment related to the NRW and the IT. So it's a complementary to what the previous presenters have presented to us. We hear from Reliant, Werner, how they do the pipe repairs and rehabilitation and lining. And then we heard also from Engineer Shahada the way they treat the ground, earth, when they come to do the pipe checking and also the laying of the pipes. And now we hear from Engineer Faris what his company is doing related to the use of equipment and IT to increase the efficiency and to do the operation and maintenance. By this presentation, we reach the end of the three presenters, and really thank you very much for it. For me, and of course for some of you, it's a very good learning and what we could do, what we could hear about, lesson learned related to the advanced water solutions. Now I leave the floor open for questions, and our friends from Oman, they have a burning one. I hope they're still keeping it. And I have also two questions I'm going to raise for Faris and for Bernard. You have a question, right? Still, you're please go ahead. Do you have a mic, or if you don't mind, please. Question to who first?
Just thank you for your thank you for all presenters.
Do you have another mic or what?
That one.
Bernard, you can have one. Yeah. Sorry. It was sporty.
First, thank you for all presenters. You really blew our mind yet. But I have one question. Can we use it for the underground, this material, rehabilitation material, can we use it for the underground concrete channel for rehabilitation?
Is it under pressure or is it gravity?
Gravity.
Gravity. If the circuit, so as I said, the material is stupid, it follows the shape. Yes, can. If the circumference is not exceeding 6.3 meters. Can be any shape. Can be arch, can be box, can be 6.3 meter, which is equal to 2 meter diameter, but in the circle.
Another question: how many years will this material will last inside the pipe or inside even the channel, yeah? So,
So the technology is on the market in the world since about 25 years now, 28 years. And we do 1,000 kilometers, 1,050 this year per year in 55 countries. The lifetime expectation as per standard is being tested, so after, but I didn't want to blow the time by presentation, this sample, so each, to close the quality control cycle, after installation, normally a segment of the installed and cured hardened pipe is taken to a lab and they test the mechanical properties, the stability, and also tightness scan to prove this is as per the requirements of the ISO standard, which says not less than 50 years. This is a requirement by the ISO standard. This is ISO 11297/4. This requirement, otherwise the technology would not be a renewal, it would be a repair, much lower grade. So this is a renewal, that means a new pipe, like equal with trenching, construction, new pipe. It's not a repair, that means the old pipe is not needed for the structure. In a repair you always have the old structure as part of the whatever, composite or something. In this technology, the old pipe is only used as the shell, the space, to have the room for the new pipe, and after it's finished, like I showed you the sample, I would say forget the old pipe, it's soil. There are two ways to treat the old pipe: excavate, transport it, dump it somewhere, which is possible, but maybe not useful. You need a dumping place, or you leave it where it was for ages and leave it there, protected, and you don't disturb all the other areas next to it. It's a decision by the SME. But technically, the old pipe is soil. It's a renewal. You have a new pipe in the existing old pipe which you don't need anymore. We need it only for the installation process to have the room. That's it.
yeah, thank you very much. Yeah. You have a, please.
Yeah.
Can we after install penetrate this material?
After the
After install, yeah.
yeah.
For some purpose, like
Actually, okay. So you want to work on it or make a connection.
no, after install,
Yeah.
we need some part is penetrated, like screen in the wall.
Maybe I didn't get the point. You mean penetrated?
Yes.
With
Penetration
what?
for
With
the
what?
Like the filters inside the deep wells, you mean?
like the filter.
You want to use
Screen in the
after you do the lining, you
Yeah.
wanted to also do some slots to use it like filters on the deep wells.
screen in
Would
the
that be
wall.
okay?
That means open.
Yeah, we drilling the line up.
Would that be possible?
Yeah,
Perforated, yeah.
it's GRP. You can drill holes in it.
Yeah, it's okay.
You can drill holes. It's GRP. You can have a driller and drill holes.
Okay.
You need just like a whatever robot or device.
Yes.
It is mechanical. You can grind it with a grinder. You can drill. You can have a connection. So disconnect, add a sleeve on it. You can handle it as GRP material, like you fix a boat. Yeah, that constructs a boat.
What will be the solution? If you need to drill inside the freshly installed GRP liner, you use a normal reinstatement crawler. Any kind of mechanical robotic crawler that has a grinder, and you control the size of the
Yeah.
holes.
I want to actually be sure it is that.
Yeah. Yeah.
Makes sense. Good question.
I have
one small question first. You mentioned that it's the maximum length what we can do for the rehabilitation is around 300 meters, and for diameter 2 meters. What are the constraints for longer?
The constraint is first the location, because this technology is suitable for straight lines. We don't go around elbows of two reasons. Because when we go with the glass fiber around, we lift a little bit away from the outer surface, and we have an excessive material which is more wrinkly in the inside. So this is not perfect. If there is no other solution, if this is the only one, but this is a concern, we don't do that normally. Actually, we avoid to do that. This is one thing. The other thing is the length of the cable of the curing machine, which you have seen before. The normal common machine got 150, 200 meters of cable, which is a day's installation. We have machines built in a truck. It's a little wider than we have been before because the cable is much more. A 350 meter, and we have for potable water a unit which can be do up to 500 meter. Very seldom, because the limit is then no more the technology itself, is how you clean the 500 meter from one step to another step. This is actually the concern then. If that can be managed, we can do 500 meter again, if the material can be transported. Because then we have quite a box.
It's also applied for the diameter.
The diameter and the weight is the limit. But normally with the excessive you transport machineries like this. But if this is the solution, then we find a solution for transportation.
Faris, you want to add something?
It's actually similar.
It's okay?
It's actually similar to what they have asked. So this only can work if there are no, let's say, connections or manholes.
Yeah. No, actually, if there are manholes, we can line through, but at the manhole, there will be later on the disconnect. So, to save time, let's say you have different segments straight, it can be lined through all the way along, but later on, you go into the manhole and reconnect whatever needs to be reconnected. But for time saving, you don't need 1 day, 2 days, 3 days, 4 days. You go through 1 day long shot, and then you make a fixing.
Thank you very much. Okay, yes, we have 5 minutes before we close the session, but I would like you, before you go, remember we had 3 companies from the private sector here. We have the Riot, the Reline, we have the, you have to say it, Herringstedt, and you have Wakila company is local in Jordan, and we knew their products and we knew their technologies. Hopefully, and you have booths, right? Please try to get in touch. And thank you so much for the attendance, and looking forward, we meet again. All the best. عندي كل
Ministry of Agriculture and